Now let's see one interesting topic, groups of small order. So tell me how many groups of order 1 are there? Groups of order 1. First you tell me how many total structures of order 1 you have. This is my question. How many binary structures you have? How many different binary structures we can have? How many different binary structure means binary operations we can have? We can have with order 1, with order 1 structure. So if your structure has order 1, then how many binary operation you can do? This we have already seen. See, if your structure has order 1, this is your structure, let's assume. So your structure is this. Then how many binary operation you can define? Only one binary operation you can define, right? Because binary operation is a function. So how many function you can define? Remember, binary operation is a function. Remember, binary operation is a function. Okay, so how many functions you can define from a comma a to a? Only one function you can define. So only this you can define, that a star a is equal to a. This is what you can do, nothing else. So how many different binary operations you can have with order 1 structure? If your structure has order 1, then only one binary operation we can have. So the answer, how many? Okay, so the only one binary operation we can have. We can only have one binary operation. Okay, let's come back to group. How many group of order 1 you can create? Let's assume, okay, how many groups of order 1 we have? How many non-isomorphic groups of order 1 we have? So let me just give this. Groups of order 1. Is this a group of order 1? Tell me. True, comma, conjunction. Is this a group of order 1? Is this a group of order 1? Yes, this is a group of order 1. Is this a group of order 1? Is this a group of order 1? This is also group of order 1. Is this a group of order 1? This is also group of order 1. Is this a group of order 1? This is also group of order 1. So can I say we have infinite number of groups of order 1? We have infinite number of groups of order 1. Let me tell you that the question will always ask you for non-isomorphic. Actually, they all are isomorphic. If you notice, let me tell you, they all are isomorphic. They have the same structure. All of them, yes, they are different. All of them are different, but they are same. Actually, they have the same structure. They have this structure. If you notice, they have this structure. Can you notice all of them have this structure? Just understand this point. Just understand this point. All of them are different. This is different from this. This is different from this. But the point is, all of them have the same structure. This. All of them have this structure. So I can say all of them are isomorphic. There is something called these all are isomorphic. We will call them all are isomorphic. All are isomorphic. Is this clear? Because they have the same structure. You can notice in all of them. Here true and true will be true. Here 0 plus 0 will be 0. True or true will be true. 1 multiplied by 1 is equal to 1. So this same structure you will get. Are you getting my point? Please understand this. So all of them are isomorphic. All of them have the same structure. And do you remember, we are talking about abstract algebra. Okay, we are studying abstract algebra. So all these things, they have the same property as this. Yes or no? Agree? This is abstract. This structure is abstract and these are specific. So all of them have the same property as this. So if you want to study this, then you don't have to study this separately. You just study this, automatically you can study this. So in the first class, I told you that this is the definition of abstract algebra. This is the abstraction. All these structures are same structure. They have the same structure like this. Okay. So this is the idea. So they have the same structure as this. So we call them isomorphic. All of them are isomorphic. This word we use, isomorphic. Isomorphic means same structure. This word isomorphic, what this means? This means exactly same structure. Okay. So now my question, now I'm changing the question. How many non-isomorphic groups are there? How many non-isomorphic groups are there? How many non-isomorphic groups of order 1 are there? How many non-isomorphic? Let me change the question. I am changing the question and I am saying how many non-isomorphic groups are there of order 1? The answer is only 1. Because this, what will you do? Just take abstract, like take only order 1. Order 1 means only one element, A. So tell me, if you want a group, then what should be this element? If you want a group, this element should be A, right? Tell me, will it satisfy all the property? Can I say this is closed? Yes, this is closed. What is the identity element? Identity element is A. What is the inverse of A? Inverse of A is A. Is it commutative? Yes, this is commutative also. Is it associative? Yes, this is associative also. Okay, so all the properties we have. So I can say every order 1 group is abelian group. Can I say this? Okay, so order 1 group, remember order 1 group, if you notice, only this order 1 group we have, only one order 1 group we have, and this is like this. So let me write E, because anyway this is identity element. So only one order 1 group we have, non-isomorphic. These are isomorphic, right? See, all of them are isomorphic. If I ask you how many isomorphic are there, see, all of them are isomorphic. So what will you say? You will say 4, you will say infinite. If I ask you how many isomorphic are there, then these are isomorphic, these are isomorphic, these are isomorphic. So there are infinite number of isomorphic. Yes or no? Like this, you can create infinite number of isomorphic. You can create. You can create infinite number of isomorphic, like this, infinite number of isomorphic structures you can create. That is the reason I am asking non-isomorphic. Non-isomorphic. This is what I am asking. So when I ask you non-isomorphic, then you cannot say that, see, these are not isomorphic. All of them are isomorphic to each other. This and this, they are isomorphic to each other. This and this, they are isomorphic to each other. So I am asking you how many non-isomorphic we have. So only one non-isomorphic we have, that is this. Only this is the possibility. Nothing else is possible. Is this clear? So I can say this is the template for all the groups. Yes, very good. Very good. This is the template. This is the template for all groups of order 1. All groups of order 1. Only one template we have. So basically the question is order 1 group, only one template we have. Like this you can understand. We have only one template. Yes or no? This is the only template for order 1 group. This is the only template. Every other group will follow this template. This is the template. This is the template of order 1 group. Template of order 1 group is like this. Okay, you have some element, this is the template of order 1 group. Now every group that you have, that will follow this template. Every group that you have, that will follow this template. Whatever group you have, that will follow this template. Every group will follow this template. Only one template we have, and every group will follow this template. Is it clear now? Is this point clear now? So basically I am asking how many templates we have. So only one template. Okay, template you can understand as non-isomorphic. So I can say how many non-isomorphic group we have? Only one. Okay, how many non-isomorphic group we have? means how many templates we have. How many non-isomorphic group? I can say that how many if I ask you how many non-isomorphic, if I ask you this, then you can understand like this. How many non-isomorphic groups of order n? It is same as how many templates of groups of order n? How many templates of groups of order n? How many abstract templates? Abstract. Now is it understood? So how many non-isomorphic groups of order n? Just find out how many templates you can create. How many templates of groups you can create for order n. So tell me for order 2, how many templates you can create? Order 2. Order 2 group. Let's take, so take abstract. Just take A comma B. Okay, so one should be identity element, right? Yes or no? Guaranteed one element should be, because I am talking about group. So there should be identity element. You must have identity element. So because you have order 2, now tell me what this will be. You know that there is no choice. There is no choice. There is no choice here. We don't have any choice, right? Do we have any choice? No. And we are talking about a group. So do we have any choice here? Do we have any choice here? We are talking about a group. We are talking about a group. So do we have any choice here? There is no choice. It should be E, because repetition is not allowed. In a group, we are talking about group. So how many templates you can create for order 2? Again, only one. Again, only one template for group of order 1. Yes or no? Is this abelian? Is this abelian? Is this abelian? And yes, this is abelian. You can just check, this is abelian. So this is the point. So order 2 group, that is abelian. Okay. Next, order 3. Order 3 groups. How many order 3 groups you can create? How many templates you can create for order 3? So definitely, because I am talking about a group, so you must have identity element. Just try this. Take a copy pen. This is very interesting thing. This is very interesting. You must have identity element, because I am talking about a group. So you must have identity element. Definitely you must have identity element. Now there is no choice here. We don't have any choice here. This will be like this, because E is the identity element. Now tell me. Now tell me. Now what? Do we have some choice here? Do we have some choice here? Can I put, see, can I put E here? Let's check. Can I put E here? If I put E here, is there any problem? What is the problem if I put E here? Then I will have to put B here. See, there is a problem. See, if I put E here, then I have to put B here, and there is a problem. And there is a problem. Okay, and there is a problem. So I cannot put E here. So I don't have any choice. I have to put B here. I have to put E here. Now automatically, because you have A comma B, so E will come here. Because you have B comma A, E, so A will come here. So again, only one group of order 1, right? Yes or no? Of order 3. Again, we have only one group of order 3. Is this clear? Only one template of group of order 3. Is this abelian? Yes, you can check. This is abelian also. You can just check it out. This is very simple. This is like playing a Sudoku. This is like a game. What about next? Order 4. How many order 4 group you have? Tell me. How many order 4 groups you have? Let me tell you that for order 4 groups, there will be only 2 non-isomorphic group you have. Means 2 templates you have. Basically, you have 2 non-isomorphic groups you have, and both of them are abelian. You have 2 non-isomorphic group, both of them are abelian. Both are abelian. So basically for order 4, there will be two non-isomorphic groups. Mean there will be two templates. There will be two templates of groups. Two templates of a group. Okay. And both of them will be actually abelian.